This is Shanghai Pudong International Airport, handling 70 flights per hour. It's one of the busiest in the world. A flight takes off or lands here in every minute. At the end of 2017, the second C919 narrow-body airliner made a successful maiden flight here. With it, the Chinese aerospace manufacturer COMAC intends to compete with Boeing and Airbus in the global market for large passenger planes. Steel pipe is a cornerstone of modern industry. The development of aircraft, motor vehicles, ships, equipment for nuclear power, wind power, and rockets are all inseparable from large, seamless steel pipes. But it takes a special kind of machinery to extrude hard metal bullets into large, seamless pipes. In Yanshan County, Chinese engineers have used their ingenuity to create a steel colossus of astonishing power. This machine is capable of producing 50,000 tons of force to extrude 40-ton steel ingots, like squeezing macaroni, into large-diameter, thick-walls, seamless pipes. Among vertical extrusion machines, it has the largest opening in the world. In the Tianwan nuclear power plant in Lianyungang, steam turbines are running smoothly. Nuclear power is the cleanest, most efficient way of generating electricity. Tianwan nuclear power plant supplies 12 billion kilowatt hours to the national grid annually, enough for a city of 9 million people. The low pressure in a casing of each turbine unit is huge and has a complex structure. It's a key component in the power station. It needs to withstand up to 9 atmospheres of pressure. High precision is needed to make it of a level that can't be achieved without a special machine tool. Harbin in China's far northeast is some 1,400 kilometers from Lianyungang. Here, a 62-year-old factory is using a super machine tool to build the low-pressure inner casing. It's the largest machine of its type in the world, and it can carve a piece of steel the size of a freight truck into any shape. It's a 10-meter CNC planer type milling machine, nicknamed the aircraft carrier of machine tools. A 50,000-ton vertical extrusion machine and the world's largest 10-meter CNC planer type milling machine, though with different appearances and different capabilities. These two super steel shapers have one thing in common: they were both made in China. In 1869, the world's first Renault bicycle made of steel tubing appeared in France. Since then, the engineering application of steel pipes has been ever expanding, and with it, the demand for them. The manufacturing process for a huge number of products today begins with steel pipes. China makes 75% of them globally. Yet China for a long time had to import high-end pipes, especially large diameter, thick walls, seamless pipes, because they can't be manufactured without a special machine tool. It took Chinese engineers 3 years and nearly 500 million yuan to build an unmatched 50,000-ton vertical extrusion machine.
Once I took a walk with my wife and I picked up a couple of corn. I counted 586 kernels on that corn. Each kernel can become a new plant. We think of the company's technology and product development processes as sowing seeds, where the harvest will be hundreds of times higher.
The 50,000-ton vertical extrusion machine has a total height of 30 meters, although half of this, the bottom 15 meters, is installed underground. In the bottom half sits the machine's hydraulic power system. Its red pipes are like arteries to transport power, while yellow pipes serve as veins to form a return flow. Its compressors, accumulators, and boosters constitute a huge heart, giving the extrusion machine tremendous power. Today, the machine is about to shape a fourth-generation primary coolant loop pressure pipe. This is a central and critical component in a nuclear power plant. The coolant circulating in it is under high pressure, has a very high temperature, and is also highly radioactive. Its performance, therefore, has a direct bearing on the plant's smooth functioning and safety. Pressure pipes extrusion will begin. Early in the morning, technicians start work in the extrusion machine's hydraulic power system, checking on its pipework. With a total piping length of over 3 kilometers, the pipework is very complex, and the technicians must ensure there are no leaks. The pipes will be full of high-pressure oil once the extrusion machine begins its work. If a leak occurs, the oil will be sprayed out as a mist, which can easily cause an explosion. The consequences will be unimaginable. Therefore, they must treat every seam with extreme care. While the inspection of the underground pipes is in progress, preparations above ground are also underway. Machine's furnace is heating the steel to be extruded. The furnace's door opens, and a 25-ton billet is slowly discharged. At a temperature of 1100 centigrade, the furnace's heat has softened the steel to a point where enormous pressure will push it out of the machine like toothpaste. A descaling machine is standing by. Because of oxidation during heating, the billet surface is covered with a thick crust of iron oxide. If the billet is sent into the extrusion machine now, the quality of steel pipe extruded will be greatly reduced. So descaling is very important. The hydraulic mechanical arm picks up the 25-ton billet and feeds it into the descaling chamber. With sparks splashing everywhere, the thick layer of scale on the surface of the billet is quickly removed. The main work of the extrusion machine will soon begin. Extrusion of the pressure pipes may be completed in a few minutes. Before that, however, a meticulous and thorough preparation must be completed. The next step is for 16,000-ton billet-making machine to work on the metal. It will push into the billet like a tightened knead dough, giving it still a more uniform and tighter texture. Now the billet, which has taken shape as a pipe, is finally about to be extruded. While the extruding machine is warming up. In Harbin, the preparations of the 10-meter CNC planer type milling machines are also underway. It's about to make the low-pressure inner casing of a nuclear power plant's turbine generator. Extreme machining is the name given to the machining of extremely large and high-precision complex curved parts. This includes laving, clamping, milling, planing, and grinding. A standard machine tool can normally perform only one of these processes. To machine complex shapes, different machine tools are needed. And since the cutter of machine tools is in a fixed position, the part needs to be repositioned and turned at different angles for work on its different surfaces. For a large object, like the low-pressure inner casing section, each rotation requires lifting, measuring, and repositioning. This not only takes time and effort, it also affects machining accuracy. The 10-meter CNC planer type milling machine uses 5 axes of motion for full versatility of positioning: the forward and backward movement of its gantry, the left and right movement of its slide plate, the up and down movement of its crossbeam and ram, the rotation of its rotary disc, and the cross swing of its swing head. By changing cutters, it can perform cutting, drilling, reaming, and grinding on all surfaces of the part. The crossbeam is its core component. The beam is 12 meters long and weighs 130 tons. Because it's suspended in mid-air, deformation under its own weight is unavoidable. Although the extent of the deformation is minor, cumulative error will cause deviation in the accuracy of the whole machine, even requiring its products to be scrapped. So how can deformation of the crossbeam be avoided?
It was extremely difficult at that time. I was so worried that I couldn't sleep at night. What should we do tomorrow, and how can we do it?
The team conducted countless trials. Finally, a so-called pre-deformation solution became the key. First, they manufactured the crossbeam with a slight upward arch, artificially causing a pre-deformation. Thus, after installation, the degree of sinking in the middle of the crossbeam was perfectly offset by the upward arch, solving the problem.
How can I put it? When there's a problem and others don't know what to do, I can solve it in several minutes. It gives me a sense of accomplishment.
The swing head of the machine has the nickname Finger of God. Assembly technician Liu Haiwang is installing heat-treated wear-resistant gears into it. The whole transmission system, consisting of more than 500 precision parts, must be mounted with an accuracy of less than 0.01 millimeters. That is less than 1/8 of the diameter of a human hair. This precision is necessary for the swing head to perform its full repertoire of complex and delicate machining operations. But these capabilities are not enough for full machining of the low-pressure inner casing. The planer-type milling machine also needs a smart brain, a CNC command system. This is on top of advanced features, including a milling head with high torque and long stroke ram, oil chamber structure digital modeling, dynamic analysis of its stiffness and spindle system, and creative breakpoint return technique. All of these are the result of technical challenges that have been conquered one by one.
This CNC planer type milling machine is much more than just a larger version of earlier products. Take trains, for example. In the past, they could only run at speed of tens of kilometers per hour, but now the speed of high-speed trains can reach 350 kilometers per hour. We only saw the improvement of speed, but the technology behind it, the difficulty of manufacturing, and the difficulty of control are completely different from the original trains. Because of this supermachine's greatly increased size, all of the manufacturing processes, methods, and techniques are completely different. That's where the challenge is.
In Yanshan, the extrusion machine is still warming up. For Li Fuhai, it has been 6 years since he completed his first successful seamless steel pipe extrusion. These days, he operates the machine to extrude 100,000 tons of steel ingots into certified pipes every year. Even so, every time he sits at the control panel, it's like the first time when he faced the extrusion machine. He is still impressed.
Really nervous. Look at these indicators of liquid level, pressure, temperature, and stroke on the screen. Every data change and every sound change makes me nervous because it shows whether the machine is running properly or not. We can't relax for a second during the process.
The process will soon arrive at the point where Li Fuhai presses the control button and the extrusion machine pushes out of the superheated steel ingot as a pipe. But it's not there yet. During the long process of descaling and pressing, the temperature of the billet has dropped. Once it cools and hardens, hot extrusion will not be possible.
Everything needs to be done at the right temperature. Strike while the iron is hot.
It's a race against time. The sun has gone down, a night has fallen. The 1100 centigrade furnace is blazing, and the machine's mechanical arm picks up the hollow billet and puts it back inside for reheating. When the billet is white hot again, a second descaling begins. With sparks cascading everywhere, another oxide layer is completely removed. Hours of meticulous preparation by 3 pieces of large auxiliary equipment will now come to a head in a magical moment. Before the billet is sent to the extrusion machine, a layer of glass powder is spread evenly over the surface of the billet. The glass powder will form a lubricating layer between the billet and wall of the working cylinder of the extrusion machine, reducing friction during extrusion and helping to shape the steel pipe. Now, the moment has arrived. The mechanical arm feeds the hollow billet into the extrusion machine. A few minutes later, a colossal force of 50,000 tons starts pushing the billet out as a long cylinder. At 3:47 a.m., next, ultrasonic flaw detection and eddy current testing will be performed on the newly made pipe. High temperature creep tests and mechanical property tests will also prove that its structural integrity and quality are impeccable. In Harbin, it's late at night. The night in Harbin is quiet and beautiful. Inside the machining workshop, work on the steam turbine low-pressure inner casing continues as normal. Zhang Lisheng, the chief operator of the CNC planer-type milling machine, has 27 years of experience in the field. Now his job is to machine the steam turbine low-pressure inner casing. Once assembled, the turbine's casing must be completely airtight, impervious to the high-pressure, high-speed steam racing around inside it. This requirement can only be met with extremely high precision in the manufacturing process. Studying the process documents is the first step. Jiang Lisheng's team has scrutinized them carefully to make sure they're clear about every detail. It's like making a battle plan. There is no room for negligence. One deviation may result in flaws and the scrapping of the whole expensive piece. To be machined, the low-pressure inner casing section has been placed on the workbed, and the next step is to install tool bits. The tool bits must be carefully chosen. Different processing steps require different tool bits. Cutting needs a cutting bit. Drilling needs a drill bit. And reaming holes needs a boring bit. Once the programming is complete, machining begins. Precision is something Jiang Lisheng is finally attuned to. Although the planer-type milling machine is equipped with a clever CNC control system, a nimble swing hand, to make this 1,000-ton machine achieve an accuracy error of less than 0.02 millimeters, or 1/4 of the diameter of the human hair, it's like a giant carves flowers on the rice. No need to say, it is still an extreme challenge to the operator's skill.
I was deeply impressed. And when I saw it for the first time, I thought that I'd be very proud if I could operate this world's largest planer-type milling machine.
Jiang Lisheng dips his finger in the iron filings on the floor from time to time and observes them carefully. What can they tell him? It turns out that alloy cutters generate heat when cutting metal surfaces, and iron filings take on different colors after cooling down from different temperatures. If the temperature is too high, that means a cutter is being pushed too hard, and machining precision will be affected. By observing the color of the iron filings, Jiang can immediately tell if the cutter is overheating, and then make appropriate adjustments. His acquired intuition comes from years of careful attention to the workings of a machine.
We work in 3 shifts. I have been working like this for over 20 years. I arrive at home at 8 a.m. and my daughter gets out of school at 10 p.m. I barely ever get the chance to see my daughter. I feel guilty. There is little communication between us.
The thick wall seamless steel pipe extruded by the extrusion machine is undergoing final tests. Before leaving the factory, ultrasonic flaw detection, mechanical property tests, and a 600 centigrade heat creep test. A pipe bender softens the tough steel pipe, making them into pressure pipes. As cooling water is sprayed on it, hot steam rises, and the 13-meter section gradually takes its final shape. Amazingly, after bending, the diameter and thickness of its curved sections are identical to those of its straight sections. Only thick wall steel pipes heat extruded by a large extrusion machine can have such flexibility. The 4th generation primary coolant group pressure pipe is finally finished.
This super equipment can affect the whole country and market. We've changed traditional casting and forging by heat extrusion, the modernization of traditional products.
Today, the seamless steel pipes made by this machine have been widely used in nuclear power, marine engineering, aerospace, and other fields. They have been an important part of China's transition from a country that manufactures the most to a country that manufactures the best. In Harbin, what started out as a rough steel casting has finally been transformed into a finished, precisely engineered steamed turbine. Inner casing section. Next, it will be shipped to its destination nuclear power plant. And once installed, it will be a key component of the plant's generator, converting the enormous energy released by atomic fission into electricity for delivery to the national grid.
It's the only ultra-large and ultra-high precision planer-type milling machine in the world. Without it, it'd be difficult for us to ensure the products we deliver the power plants achieve our design accuracy.
With the high-quality development of China's economy, not only low-pressure inner casing for steam turbines, but also components like the cross beams of high-speed stamping machines and undercarriage beams of mining excavators need industrial machine tools that can make them to required standards. One giant machine uses extreme temperature and force to push out seamless pipes of perfect integrity. The other focus is on high-accuracy machining to transform large rough castings into precisely formed machine parts. This is mega equipment from China. The secret to the creation of these engineering marvels is perseverance and dedication maintained over decades. They are the foundation on which China's future as a prosperous and confident nation can be built.
I've been in this industry for 27 years. I haven't switched to another field.
I've been doing this for 22 years. I'm an excellent welder.
Under my influence, my apprentices are perfectionists too.
Denying yourself is an important condition for moving forward.
We're developing very fast now. I wish I could live for another 500 years.
The world is undergoing dramatic changes, and China is undoubtedly one country that is changing fastest. If there's an opportunity to document these changes, it's certainly a very meaningful and worthwhile thing to do. The equipment manufacturing is very close to us. For example, we use natural gas to cook meals every day, but we wouldn't think that it comes from the desert, thousands of kilometers away. We turn on lights every day, but we never realize that the power comes from the western border area and is delivered to our homes by some mysterious pieces of equipment we don't know about. Our everyday life is maintained by some amazing mega equipment. What equipment can be called mega equipment? And what do we show in the program? Are vital questions. We've chosen these pieces of equipment in the program from over 60 pre-selected projects. They're all mega equipment, independently developed by China, embodying the highest standards of China today.
Among these three giant machines, one dominates a mine, another boss underground tunnels, then the third hoist up enormous vessels. Although with different appearances and different capabilities, they all have one thing in common. Ultra-high voltage transmission and transformer equipment, hidden in the network's core, is vital to the efficient operation of this supergrid. On the streets, cars developed with 3D printing and manufactured by intelligent machines are raising both performance, benchmarks, and living standards. This technology is building tomorrow's world today.
I've been doing this for 12 years, and I deal with cross-river tunnels. I've been working on the Three Gorges project for over 20 years.
I've been doing maintenance for 39 years.
I've been doing this for 30 years. I've devoted myself to this one thing for my entire life.
I've worked on 4-planer-type milling machines over 27 years. I've been in this industry my whole life. I'm 72, and I can still work if needed.
I've been in this industry for 20 years.
I've been here for over a decade, doing assembly and heat shrink fitting.
I've been here since the factory was built. It's been over 20 years.
I've been a welder since 22.
I've been employed at this company for 33 years, since I graduated in 1984.
This is the 28th year for me in the forging industry. My father has been working for this company since his generation.
I spent 10 years building this rotor.
For tens of thousands of parts, I can immediately tell the location and function of any of them.
I've been keeping a record of my work in the technical problem since 1978. I've been working almost every day, including weekends.
This huge machine behind me is the 50,000-ton extrusion machine. It's the largest extrusion machine our country has ever developed. We spent several years on the production of mega equipment. We went to 38 cities and regions in over 1,300 days. We interviewed over 30 companies, wrote notes of hundreds of thousands of words, and shot over 20 terabytes of video footage. Over 300 people participated, telling their stories to the camera.
The job is not well paid, and it's hard too. But if you take it as a career, you can find joy in installing and repairing machine tools.
By the time the clients were due to come and inspect the product, I had been working for 40 days straight. Without taking a shower, I decided to take a shower. When I was about to shave, someone called me, and I cut my jaw. I was afraid something would go wrong.
I always double-check everything I do. Under my influence, my apprentices are perfectionists too.
There have been times when I've cried because of the huge pressure. I did it on my own, unnoticed by others, and I can endure all the hardships myself.
I'm always nervous when installing it. I'm afraid that if this part doesn't fit, that will cause losses of hundreds of thousands of yuan. I always get very nervous and sweaty. My social media name is Rest, because I want to relieve some of my stress. I've been operating the excavator for years, and I love my job. I'll miss it after I retire. I don't want to leave my post, because I have an emotional attachment to it. I love it. I know it. Eventually, it knows me too. That's the bond.
It's like a love-hate relationship. In the past, my son rarely talked to me because I spent little time at home. I'm making up for it. I'll work hard and try to make more money. My shift starts at 5 p.m. and ends at 8 a.m. I've been working like this for more than 20 years. I arrived home at 8 a.m. and my daughter's school starts at 6 a.m. I rarely see my daughter. I feel guilty. We contribute less to our families. It's the nature of my job of water power engineering that you may only get home once every few months. They support me.
My daughter's in college. She told me I have a hard job, and she'd help me by doing more housework.
As night falls and the lights turn on, another charming night in Shanghai begins. With a constant supply of electricity, the city is as bright as day. No one realizes that a steel dragon is burrowing right under their feet.
When making this program, we were thinking how to make a documentary on industry more appealing and more attractive, besides stories and images. What else is missing? Thinking about that, we contacted Wu Gong, an actor from Beijing People's Art Theater. We hoped he would come to dub for the show. In the meanwhile, bring something new to the documentary.
"1,400 kilometers to the north lies the Herwusu mine of Inner Mongolia. In a tremendous pit echoes the roaring sound of a steel giant. In a super factory, transformer equipment with the highest voltage class in the world is being built. More than 400 kilometers north of the Shangjiang River, a marvelous lifting show is being staged. Smelting, casting, heat treating, induction quenching, and machining. Each process is a challenge for the creators of mega equipment. Behind every success lies decades of perseverance. From a world-renowned orthopedic surgery robot to amazing 3D printing. From the heart of great ships to the West-East electricity transmission project. From the heart of nuclear power to the West-East gas pipeline project. They all have a common name: Chinese equipment.
My parents are farmers. The age difference between me